NASA just revealed what they're calling possible signs of life from Perseverance's exploration of Jezero crater on Mars. But as always, the physics, the chemistry, and even the politics of science might tell a more complicated story. What if the strongest evidence yet for life on Mars isn't really about life at all? Let's dive in. I'm Ben, this is Physics or Bust. Perseverance has been exploring Jezero crater, a place where an ancient river once flowed into a lake. Why here? Because river deltas are nature's filing cabinets. They trap sediments, and those sediments can trap evidence that indicates life existed. If Mars ever hosted biology, Jezero is one of the best places to look. So when NASA makes a big announcement here, it's worth paying attention. We'll dig into the physics in a minute, but first, if you like this video, you'd probably like this book. I've got a link in the description below. I do get a small commission, but it wouldn't cost you any extra. One of the most intriguing things Perseverance has spotted are the so-called Jaguar Spots. These are the dark, blotchy markings in this sample that almost look like microbial colonies etched into stone. On Earth, patterns like these can form when microbes grow across rock surfaces, leaving behind chemical stains that persist for billions of years. But that's not all. Perseverance also found that many of these rocks are rich in olivine, the greenish material over here. On Earth, olivine is incredibly reactive with water. When olivine breaks down, it can release hydrogen gas and heat, a potential energy source for microbes. That makes olivine-bearing rocks not just interesting, but an indicator of possible habitability in this environment in the ancient past. Scientists also identified carbonate veins running through the rocks, minerals that usually form in water. On Earth, carbonates often trap and preserve biosignatures, essentially fossilizing the chemical whispers of ancient life. These tend to form in evaporating lakes and salty brines, exactly the kind of challenging environment where extremophile microbes thrive on Earth today. Layer all of this together, Jaguar spot patterns, olivine, carbonates, and include the fact that Perseverance's spectrometers picked up complex organic molecules, and you start to see why NASA got excited. These aren't just isolated hints. They form a convergence of evidence that Mars once had the chemistry, the water, and maybe even the energy sources that microbes would have needed. And that brings us to an important question. How confident should we be that this really points to life? NASA actually has a framework for weighing claims like this. It's called the Confidence of Life Detection Scale, or COLD scale. A 7-step ladder that goes from level 1, we found something interesting, to level 7, we have a conclusive proof of life. But where does Perseverance's new evidence fall? If we can assume no contamination, we're at level 3. We've found something consistent with biology, we've even ruled out a few non-biological explanations, but it's still far, far away from Mars once had life. Because here's the reality. They can say they found organic compounds, but that doesn't necessarily mean life. Volcanic activity can make them. Meteorites can deliver them. Even purely chemical reactions can leave organic compounds because it just means that there are carbon-containing molecules that could have served as building blocks for life. Not that there was life. Those Jaguar spots? They might be stains from ancient microbes, or they might just be the result of mineral weathering. So while the discovery is exciting, science demands we ask, is there a simpler, non-biological explanation? And I'll be honest, I'm not as excited about this announcement as I feel I should be. Part of that is timing. Why make this declaration now? Okay, yeah, the paper came out, but could it be less about science and more about building momentum for the Mars sample return mission? That mission is expected to cost billions of dollars. Billions! Just to bring back the rock cores Perseverance is caching right now. Announcing possible signs of life might be exactly the kind of story needed to get public and politicians to fund it. Now, to be fair, the argument for sample return is relatively strong. The instruments on Perseverance are great, but they're still limited. Here, scientists can run isotope ratio tests, study mineral textures at the nanoscale, and even search for faint molecular structures that rovers can't detect. In the end, it all comes down to physics. Spectroscopy, isotopic fractionation, and the thermodynamics of water-rock interactions. These are the physical tools that help us separate geology from biology. So where does that leave us? Perseverance's Jaguar Spots and olivine-rich rocks may be the strongest hint yet of ancient life on Mars, or they may just be Mars geology doing a very convincing impression. Right now, the evidence sits at about level 3 on the confidence of life detection scale. Interesting, but far from proof. The bigger question is, do these discoveries justify a multi-billion-dollar sample return mission today? Or should we wait until humans can collect Mars rocks in person? I'd love to hear your take in the comments. But whether it's life or just geology, the physics behind it is worth busting wide open. For more space and science updates, make sure to like and subscribe, and remember, keep asking questions. I'll see you on the next video.